Welcome to the deep dive. We grab a pile of research and, well, we give you the rundown so you're ahead of the curve. Today we're digging into something really fundamental. How theoretical philosophy isn't just, an interesting side discussion for AI, but might actually be the key, the absolute bedrock for solving some of the deepest conceptual and, frankly, technical problems AI is facing right now.
That's exactly right.
Yeah.
And our mission today really is to show you that the biggest hurdles stopping us from getting truly smart, generally capable AI, they aren't just about needing faster processors or even bigger data sets. They are, in many ways, ancient philosophical questions just showing up again, but this time in lines of code. The sources we looked at, they're pretty much in agreement. Philosophy is absolutely vital if we want AI to move past just being a really sophisticated parrot and get closer to, well, genuine understanding.
Okay, let's unpack that. Because, when you see current AI systems stumble, it often feels like a failure of meaning, doesn't it? An AI can process, I don't know, a billion facts about an apple, its chemistry, color values, where it's sold, but it doesn't seem to get what an apple is, fundamentally. Which brings us straight to the first and maybe the most critical point, the grounding problem.
The grounding problem. Yes, that's the big one. At its heart, it's asking, how can these systems, which really just shuffle symbols around based on algorithms, syntax, abstract data, how can they ever connect those symbols to real, tangible meaning in the world? The system knows the letters A, P, P, L, E, but it doesn't grasp the actual sticky, sometimes bruised, real-world thing that word represents.
And our sources really zero in on why the current approaches often fall short here. There's a key insight, particularly from Dascal. He points out that the sort of old paradigm that we've been using treats knowledge like it's all static, like it's just structured, rule-based data.
Exactly. Think of it like an old encyclopedia. Everything's neatly defined, rigid, doesn't really change. Dascal's point is that if AI is ever going to really progress, it has to ditch this traditional fixed idea of what knowledge representation is. Because if a system only deals with static structures, how can it possibly cope with the dynamic, constantly changing, messy reality we live in?
So if we follow that line of thought, the way we're even representing knowledge in these systems is sort of fundamentally flawed for that task. Vernon and Furlong pipe in here too, noting that how we handle representation in cognitive systems often seems stuck in these older philosophical ideas about knowledge. Knowledge is fixed, objective, totally separate from context.
Right, and this is where philosophy offers a way forward. Vadinsky argues that looking at philosophical approaches to how humans think is super relevant here. Why? Because philosophy provides conceptual answers for how an AI could potentially generate meaningful actions from symbols. But it requires a big shift in thinking, away from just static representation towards active interpretation.
Okay, interpretation instead of representation. But what does that actually look like for an AI? How do you code for meaning if the meaning itself keeps shifting?
Well, it means building systems that are designed for context sensitivity. They need to factor in interaction, temporality, the role of time. See, interpretation means the meaning of a symbol isn't fixed. It changes based on the situation, maybe the conversation history, maybe even the time of day, which is, of course, how we humans understand things. Interpretation is an active process, not passive reception. You're aiming for systems that get that the word bank means something totally different if you were just talking about money versus talking about a river, right? Philosophy basically gives us the conceptual toolkit to handle that kind of ambiguity.
That raises a really crucial point about the systems we actually have running today. If we link this need for interpretation back to the architecture, we start to see that the way they're built rests on philosophical assumptions, and some of those assumptions are now actually holding things back.
Oh, absolutely. The historical DNA of modern AI, it's surprisingly old. Take Aristotle. His work inspired formal logic, the whole symbolic tradition, this idea that you can create perfect logical structures for reasoning. And while that gave early AI its power in, say, clarity and precision, Vernon and Furlong point out that this heavy reliance on formal logic also became a bottleneck. It really struggled with uncertainty, with vagueness, with all the messy stuff in the real world that doesn't fit neatly into logical boxes.
And we can't forget Descartes either, can we? That classic mind-body split. You can almost literally see it in the way we traditionally separate hardware and software in computers. The thinking part distinct from the doing part. Our sources do note that this kind of strict dualism is maybe becoming less relevant now with hybrid models emerging, but it's a clear example, isn't it? Philosophical ideas shaping architectural limits that engineers then have to sort of work around.
So that leaves us with these two main camps of models today, both with these philosophical lineages and pretty clear limitations. On one hand, you've got pure symbolic AI, you can think of it like a, I don't know, a super precise accountant. Excellent rigor, clarity, but throw it some ambiguity, some vagueness, or a contradiction it wasn't explicitly programmed for. It just grinds to a halt.
And then the other side, connectionist models, the neural networks, the deep learning stuff. Maybe think of those as like a highly intuitive pattern spotter, amazing at recognizing faces or predicting what's likely to happen next based on past data. But here's the catch. That prediction, that pattern recognition, it doesn't hold any actual significance for the system itself. It's kind of hollow, right?
Mm.
The system doesn't conceptually grasp why the pattern matters. It just knows there's a correlation.
Exactly. Which is precisely why philosophical concepts are becoming so critical for designing the next wave. Hybrid architectures. Cognitive systems. The system needs both the accountant's precision and the artist's intuition working together. Vedinsky makes a strong case that philosophy is necessary here because it offers these layered architectural frameworks. And this isn't just about neat software design. It's the conceptual structure that allows for flexibility, for dynamically restructuring knowledge based on the situation, especially in unpredictable worlds.
Wait, hang on. Why do we need philosophy specifically for layering? Isn't that just good software engineering practice these days?
It goes a bit deeper than just the engineering how. Engineering tells you how to build the layers, the specs. Philosophy helps answer the why and the what. What should these layers represent? How should they interact to actually create meaning? Not just process data. It's about the conceptual organization of intelligence itself, not just the implementation details.
Ah, okay, I see the distinction. So we're talking about the blueprint for an artificial mind, essentially. And a key idea here is something called the theory of stratified perception. Is that right? The idea is that this creates distinct conceptual layers, so the system can do high-level stuff like reasoning and planning by using the information coming up from the lower layers that are doing the more direct empirical learning, the pattern matching.
Precisely. It sets up a kind of feedback loop. The lower-level association learning feeds insights upwards to the symbolic reasoning layer, and that higher symbolic layer can then guide or constrain the lower-level learning. It's a two-way street. A really good practical example of this is the Clarion cognitive architecture. It explicitly tries to leverage both connectionist learning and symbolic reasoning to control behavior effectively in complex situations. Philosophy helps bridge that crucial gap, the one between just extracting patterns from data and actually using that information for precise, goal-directed, meaningful action.
Okay, now this is where things get, well, even more complicated maybe, because we're moving from how to build these things conceptually to how we should use them responsibly in the world. As these hybrid systems get smarter and more woven into our daily lives, the technical design challenges seem instantly tangled up with really difficult ethical questions.
Oh, it's a massive philosophical knot to untangle, Langlois and their colleagues. They observe something pretty worrying, that often AI ethics gets boiled down to just a simple checklist of principles. And they argue, quite forcefully, that this reduction turns ethics into little more than an exercise in branding, like corporate PR. It's not a serious attempt to really grapple with the deep social and environmental consequences these technologies can have. What you end up with is this widespread lack of coherence and, frankly, a lack of real practical bite in how ethics gets implemented.
So we're not just talking about getting companies to sign a pledge. We need ethical frameworks that are robust, philosophically grounded, and can actually guide decisions in tricky real-world scenarios. Which is why frameworks like the Montreal Declaration are gaining attention, right? Because they try to offer concrete guidelines that are rooted in established philosophical thought Western tradition, mainly, but aiming for broader relevance.
That's the goal. The Declaration builds its structure around 4 core philosophical pillars: human well-being, respect for autonomy, justice, and solidarity. But importantly, it doesn't just stop at those high-level ideals. The real value is in the specific recommendations that try to translate those abstract concepts into, well, actionable requirements.
Yeah, let's pull out a couple of those specifics for people listening, because they go way beyond just, do no harm. For example, the Declaration explicitly says systems should actively avoid increasing existing injustices. That means designers have a positive duty to fight against the gender biases, the racial biases that are often lurking in the training data itself.
Exactly. And it goes further. It mandates promoting sustainable development, enhancing human autonomy, for instance, by pushing back against tech designed to be addictive or manipulative. But perhaps the most striking philosophical stance is the emphasis on minimizing risk. They argue for minimizing risk right down to the bare minimum. And get this, they even state that developers might be ethically required to forego developing a technology entirely. if the potential unforeseen dangers can't be properly understood, accounted for, and genuinely avoided.
Wow. That idea that you might actually have to not build something powerful because the philosophical risk is too high,
Yeah.
even if it's technically feasible, that feels like a fundamentally cautious philosophical position that the tech world often just steamrolls past in the rush to innovate and deploy.
Precisely. And Langlois et al. Really hammer this home, ignoring these deeper philosophical guidelines. It has serious negative knock-on effects for society. Things like undermining public trust, eroding civic engagement, creating or worsening social inequalities and injustices. The philosophy isn't just window dressing, it's supposed to provide the actual moral compass and the structure for genuine accountability, not just ticking a box.
Okay, so bringing this all together, we spent a lot of time on what philosophy gives to AI. But you mentioned it's reciprocal. AI actually feeds back into philosophy too. It sort of turns these abstract ideas into things you can test.
It really does. It creates a kind of new laboratory for exploring ideas about the mind. AI development helps to validate or sometimes challenge theories that philosophers have debated for centuries. Vernon and Furlong confirm this. They point out how core philosophical concepts from logic, from theories of meaning, text analysis, automated reasoning have been actively incorporated into AI. And that process of trying to build it often forces philosophers themselves to sharpen their own definitions to get more precise.
And those hybrid systems we talked about earlier, the ones mixing logic and learning, they sound like the perfect test beds for this.
They really are. Vadinsky highlights this. Hybrid cognitive systems, especially when they're embodied in robots or physical computers, are almost ideally suited for testing philosophical theories. Why? Because you can systematically change the inputs, tweak the outputs, and crucially, you can actually go in and modify the internal control structures, the memory, the reasoning mechanisms. So the grand experiment about the nature of thought, it's no longer just happening in an armchair or a seminar room. It's happening in code, in simulations, in robots navigating a room. By trying to figure out how symbols get their meaning inside an artificial system, how symbolic reasoning interacts with raw pattern recognition, we don't just learn how to build better AI, we potentially gain really deep insights into how we work, how humans conceptualize the world, how we form beliefs, how we build knowledge. It's this fascinating self-reflective loop for understanding intelligence itself.
That's the really exciting part, isn't it? Understanding ourselves better by trying to build intelligent machines.
So, the final synthesis here. Theoretical philosophy isn't just helping AI, it's providing a truly transformative contribution. It lays the conceptual groundwork for AI's future architecture, its ethical navigation, and it demands we adopt a much deeper, more nuanced understanding of what representation and meaning are all about. Moving beyond simple symbols to appreciating how intelligence, including our own, is embodied, situated in the world, and fundamentally dynamic.
Which leaves us, and you, with a final, pretty provocative thought to chew on. Consider this. Even our most advanced, cutting-edge AI today, these complex hybrid systems, are still wrestling with limitations that trace back 2,000 years to formal logic, inspired by Aristotle. So what if we need completely new philosophical starting points? Concepts that radically break from the symbolic tradition, from the old dualisms that still echo in our tech. What undiscovered, or maybe rediscovered, philosophical ideas might fundamentally reshape the next generation of AI? What new concepts should AI researchers be experimenting with right now if they truly want to break the current mold?